Hello students, let us start with a new concept called as coordinate geometry. In class 9th, we have learned certain important definitions related to coordinate system. We learned rectangular coordinate system in which the x and y axis, they are perpendicular to each other, they meet each other at a point called as origin. Horizontal line is the x-axis represented with x dash. Vertical line y dash is the y-axis. If there is a point on a plane, this particular point will be at some distances away from x-axis and the y-axis. We denote the point with a letter followed by ordered pair. Here, this distance is 5 units, which is from y-axis, and this distance is 2 units, which is from x-axis. So the point is denoted as 5, 2. The letter A followed by ordered pair 5, 2. This 5 is called as abscissa and 2 is called as ordinate. Abscissa is the distance away from y-axis. Ordinate is the distance away from x-axis. Here, abscissa is nothing but the x-coordinate and ordinate is nothing but the y-coordinate. You need to note, if there is a point on the x-axis, the point is denoted with x, 0. If there is a point on y-axis, it is denoted with 0, y. With this basic definition, we shall begin the chapter. In this chapter, you have got very important concepts like distance formula, midpoint formula, section formula, and a formula to find area of a triangle if it is there in a plane, if coordinates of the triangles, points of the vertices of the triangle is given with the coordinates. Let's begin with distance formula. As we know, the coordinates of 2 points in the plane fix the positions of the points in the plane and also the distance between them. The distance and the coordinates of 2 points are related by algebraic relation, which is depicted in this figure. Look at the figure here. There are 2 points m and n. M is having the coordinates x1, y1, which means the point m is x1 units away from y-axis and y1 units away from x-axis. Similarly, there is another point n represented with x2, y2, which is having x2 as x coordinate, means x2 units away from y-axis. This is represented here, x2 units away from y-axis and y2 units away from x-axis. Let x1, y1, x2, y2 are the points in the plane. Ox and oy, they are being rectangular axis of references. Let us draw MP perpendicular to OX, MP perpendicular to OX, NQ perpendicular to OX, and MR perpendicular to NQ. MR is perpendicular to NQ. Here, MNR is a right angle triangle. According to the definition of coordinates, OP is x1 units, MP is y1 units, OQ is x2 units, NQ is y2 units. Here we require the length of MP, which is nothing but the length of PQ, which is also same as OQ minus OP. So we get the length of MR as x2 minus x1, and we require the length of NR. NR is nothing but NQ minus QR, NQ minus MP. This distance MP and QR, they are the same. So we get the distance NR as y2 minus y1. Now with this, I'll consider the right angle triangle. Here is a right angle triangle. Right angled at R. The hypotenuse is MN. Other two sides are MR and NR. So by using Pythagoras theorem, we get MN square equal to MR square plus NR square. Earlier, we found the length of MR. The MR length was x2 minus x1 and NR length was y2 minus y1. Let us substitute it here. The distance between M N is denoted with the letter D. So we get D square as x2 minus x1 the whole square plus y2 minus y1 the whole square. Therefore, the value of D will be a root of x2 minus x1 whole square plus y2 minus y1 whole square. The distance between the 2 points x1, y1 is given by the formula root of x2 minus x1 whole square plus y2 minus y1 whole square. That is nothing but the difference of x coordinate squared plus difference of y coordinate squares taken under root. Their sum is taken under root. This formula is called as distance formula. How do we apply this distance formula in finding the distance between the 2 points? If there are 2 points here, say 2, 3 and minus 1, minus 1, these are the 2 coordinates. In this, if you want to find the distance between them, we will take square root of minus 1 minus 2 whole square plus minus 1 minus 3 whole square. Here minus 1 added to minus 2 will be minus 3. Minus 1 added to minus 3 will be minus 4. Therefore, we get under root minus 3 square plus minus 4 square. Root of 9 plus 16 is root 25, nothing but 5. Therefore, the 5 units is the distance between these 2 points. Just remember, the distance between the 2 points is always positive. The distance of point x, y from the origin 0, 0 is given by root of x minus 0 the whole square plus y minus 0 the whole square, which implies root of x square plus y square. The distance formula d square is given by x2 minus x1 whole square plus y2 minus y1 whole square. Should be understood as an algebraic relation between the 5 variables, the coordinates x1, y1, x2, y2 and the distance. Given any 4 of them, the 5th variable can be found. Let us solve a few problems to understand distance formula. First problem is, if the distance between the points 5, minus 2 and 1, a is 5, find the value of a. We know that the distance between x1 y1 and x2 y2 is given by d equal to under root x2 minus x1 the whole square plus y2 minus y1 the whole square. Here what is x2? Here x2 is 1, x1 is 5, y2 is a, x2 is, sorry, y1 is minus 2. The distance between them is given as 5 units, so 5 is equal to root of x2 minus x1, which is 1 minus 5 whole square, plus y2 minus y1 is a, minus of minus becomes positive 2 whole square. This implies 5 equal to root of, this is negative 4 squared, which is 16, plus a plus 2 whole square. If you square on both the side, we get 25 equal to 16 plus a plus 2 the whole square. This implies a plus 2 whole square as 25 minus 16, which is nothing but 9. Therefore, a plus 2 will be plus or minus root of 9. So a plus 2 is plus or minus 3. We get the value of a as negative 2 plus or minus 3. Therefore, there will be two values of a, positive 1 and negative 5. Let us take the second one. The coordinates of points on the x-axis which are at distance 5 units from the point 6, minus 3. Here they have given that the point is on x-axis. Earlier in the note we have seen that the point on the x-axis is given by x, 0. So let me consider that. Let the coordinates of the point on the x-axis be x, 0. Distance formula says that the distance between the coordinates is given by x2 minus x1 whole square plus y2 minus y1 whole square. Now, taking x1 y1 as 6, minus 3, x2 y2 as x, 0, what do we get the distance between them? They have given that the distance between them is 5 units. So 5 will be equal to under root x minus x, x2 minus x1 whole square, x minus 6 whole square plus 0 plus 3 whole square. Now squaring on both the sides, we get 25 equal to x minus 6 whole square plus 3 square is 9. To simplify this, I'll transpose 9 to the other side. I'll get x minus 6 whole square as 16. Therefore, x minus 6 will be plus or minus 4. This implies x value is positive 6 plus or minus 4. So x value can be 6 minus 4 or 6 plus 4. So the values of x are 2 or positive 10. Therefore, the required points on the x-axis are 2, 0 and 10, 0. These are the 2 points. Let us have a look at one more question. Here the question is, which point on the y-axis is equidistant from points 12, 3 and minus 5, 10? As we have learned, the point on the y-axis is given by 0, y. So I'll consider let the required point on the y-axis be 0, y. So according to the question, it's given that 0, y is equidistant from 12, 3 as well as minus 5, 10. So the distance between these 2 points and these 2 points are equal. If I mention this point as A, this point as B, and this point as C, then AC will be equal to the length BC. What is the length of AC? It is root of x2 minus x1 12 minus 0 whole square plus y2 minus y1 3 minus y whole square. This will be equal to the distance BC. x2 minus x1 whole square is negative 5 minus 0 whole square plus positive 10 minus y whole square. Now there is under root on both left hand side and the right hand side, so you can square on both the side so that the square root will get cancelled. 12 minus 0 is 12, 12 square is 144 plus 3 minus y whole square should be treated as a minus b whole square. So 3 square plus y square minus 6y, which is equal to negative 5 square is 25. Again, you'll make use of a minus b whole square formula. So 10 square plus y square negative 20y. Let us further simplify this. We get 144 plus 9 plus y square negative 6y, which is equal to 25 plus 100 plus y square negative 20y. Here the y square are positive on both sides, so they get cancelled. We will be getting minus 20y. When you transpose to this side, it becomes positive, so we get the result as 14y, which is equal to 125 minus 9 minus 144. Simplify, we get negative 28. Therefore, the value of y we get as negative 2. Therefore, the required point is 0, minus 2. Let us take the next question. Find the values of A such that PQ is equal to QR, where PQR are the points whose coordinates are 6, minus 1, 1, 3, A, 8 respectively. Let's take up the distances one by one. What is the length of PQ? PQ length will be under root 6 minus 1 whole square, the difference of x coordinates plus the difference of y coordinates, which is nothing but root of 5 square plus negative 4 square. 5 square is 25 plus negative 4 square is 16. We get as root of 41. Let us find the length of QR. QR will be under root 1 minus a whole square plus 3 minus 8 whole square, which is nothing but 1 minus a whole square plus 3 minus 8 is negative 5 square. On further simplification, we get 1 minus a whole square plus 25. It is given that PQ and QR, they are equal. Given PQ equal to QR implies root 41 equal to root of 1 minus a whole square plus 25. Now these two roots, they get cancelled if you square on both the sides. So I'll cancel them. This implies 41 equal to 1 minus a whole square plus 25. Let us transpose positive 25 to left hand side. We get 1 minus a whole square as 16. So 1 minus a, we get it as plus or minus 4. Therefore, the value of a will be positive 1 plus or minus 4. This implies the value of a is negative 3 or positive 5. Question number 5. Find the points on y-axis, each of which is at a distance of 13 units from the point minus 5, 7. I'll denote it by a letter. A minus 5, 7 be the given point and let P0, y be the required point on the y-axis. Then according to the question, the length PA becomes equal to 13 units. The distance PA is nothing but under root 0 plus 5 whole square plus y minus 7 whole square, which is equal to 13. Let me square on both the sides. I'll get 25 plus y minus 7 whole square, which is equal to 169. So y minus 7 whole square will be 169 minus 25, which will be 144. So y minus 7 we get as plus or minus 12. The value of y will be 7 plus or minus 12. Therefore, the value of y is 19 or negative 5. Therefore, the required points are 0, 19 and 0, negative 5. I'll take a few questions related to distance of a point from the origin. We learned that the distance of the point ax comma y from the origin 0, 0 is given by x minus 0 whole square plus y minus 0 whole square. Therefore, the distance between them is OA equal to x square plus y square. Based on this, few questions. The first question is, find the distance of point 6 comma minus 6 from the origin. Let me consider the point M to be 6 comma minus 6 be the given point, and O representing the origin 0, 0 be the origin. Therefore, the distance will be OM, which is given by under root 6 minus 0 the whole square plus negative 6 minus 0 the whole square. Square of positive 6 is 36, square of negative 6 is also 36, so we get a root of 36 plus 36, which is root of 72, nothing but root of 8 multiplied to 9, 8 9s are, right? 8 is nothing but 2 multiplied 3 times and 3 multiplied 2 times. Therefore, we get 2 into 3 root 2, which is equal to 6 root 2 units. Second question related to the distance from the origin. Find the distance between the point minus 12, 5 from the origin. As we have done it earlier, I'll consider let M to be the given point, minus 12, 5 be the given point, and O 0, 0 be the origin. Therefore, the distance between these 2 points is given by OM. This will be root of minus 12 minus 0 the whole square plus 5 minus 0 whole square, which will be root of 144 plus 25 is root of 169. It's a perfect square. We get it as 13 units. Similar, one more question. I think this you can solve it. I'll be giving you the answer. The answer for this question, the distance will be 17 units. Let us take up few questions of distance formula in geometry. This is completely application based questions. Few of them I'll discuss here. The first one is, show that the points A 8, 3, B 0, 9 and C 14, 11 are the vertices of isosceles right-angled triangle. To check whether it is an isosceles right-angled triangle, two things must be done. the first thing to be done is we have to show that two of the sides are equal, and one more thing to do is we have to show that the sides will satisfy Pythagoras triplet. Let us first find out the distance between AB. The distance AB will be given by under root 0, minus 8 whole square plus 9 minus 3 whole square. 0 minus 8 is negative 8. When you square it, we get 64 plus 9 minus 3 is 6. On squaring, we get 36. This will become root 100, which is 10 units. This is the length AB. Let's find the length BC. BC is under root 14 minus 0 whole square plus 11 minus 9 whole square. Here it is 14 square, which is 196, plus 11 minus 9 is 2, 2 square is 4. We get a root of 200, which is nothing but 10 root 2 units. Here the two sides, they are not equal. Let's find out one more side, AC or CA. It will be root of 8 minus 14 whole square plus 3 minus 11 whole square. 8 minus 14 is negative 6. When you square it, it becomes 36 plus 3 minus 11 is 8. On squaring, 64. It is root 100, nothing but 10 units. Observe these three sides here. From the length AB square plus AC square, we get 100 plus 100, which is nothing but 200, which is same as BC square. This implies AB square plus AC square equal to BC square, which implies it is a right triangle, a right angled triangle. And observe, AB and AC, they are equal. This implies it is isosceles triangle. Therefore, I can conclude that the triangle ABC is an isosceles right triangle. Next question. The point A 2, minus 4 is reflected in the origin on A dash. The point B minus 3, 2 is reflected in the x-axis on B dash. Compare the distances AB and A dash B dash. The point A2, minus 4 is reflected in the origin on A dash. This implies that the coordinate of A dash will be negative 2, positive 4. Since it is reflected, I have to consider negative 2 and positive 4. Same way, the point B minus 3, 2 is reflected in the x-axis on B dash. This implies the coordinates we have to consider as -3, -2. Since it is x-axis, I have to keep the same x-axis and the value of y-axis only to be changed as -2. In the earlier case, since it is reflected on origin, I have to consider the change in sign of x coordinate and y coordinate also. Let me find out the distance AB. AB will be a root of 2 minus of -3 whole square plus -4, -2 the whole square. Let's find. It will be 5 square plus -6 square. This will be equal to root of 25 plus 36, which is equal to root 61. Since it is a distance, I'll mention as some units. Let us find A dash, B dash. It will be root of -2, negative of -3 whole square plus +4, negative of -2 whole square. This will become equal to root 1 square plus 6 square, which is root of 37 units. Therefore, the length AB and A dash B dash, they are not equal. Let us solve one more question. This is one of the important questions, and this will be the last question for today's session. Prove that the points A, B, C, D, coordinates you can refer, they are the vertices of a rectangle. Probably it's not a rectangle, it has to be a square. Correction in the question. Prove that these are the points of a square. Let me consider the quadrilateral. If I name this as ABCD, the diagonals will be AC and BD. Let us find each of the side. AB will be root of 5 minus 1 whole square plus 4 minus 2 whole square. We get it as root of 16 plus 4, which is root 20, nothing but 4 times 5, so it is 2 root 5 units. This is the length of AB. The length of BC here will be 3 minus 5 whole square plus 8 minus 4 whole square. We get it as root of 4 plus 16, nothing but root 20. We got same 2 root 5 units. Let's find the length CD. CD will be root -1, -3 the whole square plus +6, -8 square. So it is root 16 plus 4. We get 2 root 5 units. Let's find the fourth side, DA. This will be a root of 1 plus 1 whole square plus 2 minus 6 whole square. This will be root 4 plus 16, we got again 2 root 5 units. All sides have become equal now. Thus, we have all the sides equal. AB equal to BC equal to CD equal to DA. Let us find out the diagonals also. AC will be 3 minus 1 whole square plus 8 minus 2 whole square taken under root. This will be equal to root of 4 plus 36, which is a root of 40, nothing but 2 root 10 units. What about the other diagonal, BD? BD will be root of minus 1 minus 5 whole square plus 6 minus 4 whole square. This will be root of 36 plus 4. We got root 40, which is 2 root 10 units. Here, the diagonals AC will be equal to the diagonal BD. Therefore, quadrilateral is having all sides and diagonals equal. Therefore, ABCD is a square. With this, I'll conclude today's session. In the next session, we shall take up another important concept called as section formula. That's all for today's session. Thank you.